Alright. Okay. Anything else from homework that I can just riff on endlessly? Could do more and more problems. It's not really the best way to get questions from you. No more homework questions? So, just to go over what we've done so far in Chapter 7, let me ask you this. Has everybody got this here?
No, hang on.
Okay. Oh, thanks, Rick.
I'm going to go talk to you.
I got you, buddy. Don't worry about it. You're fine. So guys, this is exactly a problem that you would see in the homework and exactly a problem you'll see on the test. And it's on the practice test I'm going to give you here in a minute. I give you a set of numbers. This little squiggly line just means a set of stuff. Out of these numbers up here, are there any that are counting numbers?
Yeah.
Which ones? Out of the set of numbers up here, which ones are counting numbers? So if you say 1, I'm a little concerned.
The 4 and the 5, the 4 and the...
4 is, but negative 5 is not.
Oh, I didn't see that negative sign. I didn't put these back on.
I'm sorry, buddy. I wasn't trying.
Yeah.
I'm like, Jesse didn't have his glasses on. Yeah.
Just the 4.
Just the 4, I love it. So counting numbers are those that came naturally to us. I got 1 finger, 2 fingers. The idea of 0, and especially the idea of negatives, had to be invented later. Now the weird thing about the whole numbers in this case, what do whole numbers add to counting numbers? 0. Is there any 0 up there? No. So the only whole numbers, when do the negatives get added? The next step, integers adds the idea of negatives. So the whole numbers here will still just be 4. Is there a 0 up there? No. So again, it's only from the set of numbers that I give you. So I'm not asking you to define these. I'm asking you to pick out the ones that match these. The same thing the homework's going to ask you, same thing I'm going to ask you on the test. What about integers? So watch how you can always just take what you've written already, and now you're going to add to it. What do integers add? They add the idea of negatives. So now I've got 4 and negative 5. What's the next level? Yeah, rational. So these are rational. 4, negative 5, and rational adds the ideas of fractions, right? Ratios. So what else goes here? Definitely the 2 over 7. Something else too? Definitely not this guy. It's definitely this guy because this is 112 over... This is 112 over 1,000. So any decimal that stops is automatically a rational number because it's just a fraction. Right? With the bottom that's related to 10. That's why I can write it like a decimal. Why can't square root of 7 be there? Because square root of 7 is not a decimal that ends. Square root of 7 would be a decimal that would just go forever. Any square root that I can't do is in the next group, the freaky group, the irrationals. Irrationals is just everybody left over. All the freaky stuff. So the only thing that goes in there is square root of 7. That's it. And then together, this and this should be everything. Because if they're not rational, they must be irrational. I like it. No! No, of course you do. Rick's gone. I guess he got it. Okay. I did have a teacher once that would, as soon as he wrote something down, he'd erase it. It was just like, we'd ask him not to, and he would stop for a while, and then he'd start doing it again. It was just part of his, it was just a habit. Like, damn! So, So thankfully I don't do that. Sure. Okay. I mean, so you need to know these names. You need to know counting numbers, whole numbers, integers, rational, irrational. You have to know what they mean. Because I'll give you, and there's problems in the homework just like this. I like it. So what would this be? No, what is square root of 9? It's 3. So what kind of number is this? It's a whole number. It's also a counting number. It's also an integer. It's also a rational. Yeah. So every number that's a counting number is all of these. Because what does whole numbers do? They add 0 to these. So every one of these is also a whole number plus 0. Every one of these is also an integer plus their negatives. Every one of these is also a rational number plus all the fractions.
So if that was on the test, we write it like that, and then we put A, B, C, and D.
No, so
I mean, no, not E.
I'm not going to ask you like I just did. I just wanted to ask you a different way. I'm going to ask you like this. So let me give you one more of those. So the same questions for this set here. No C shit.
Yeah.
Alright, so the same question, right? Yes, sir. Don't say the answers yet. Don't be helping them out. She's got a good teacher most of the time.
Hey, one of them ain't even a number, is it?
Well, we should know what this is,
Yeah.
right? What is this?
That's going to be irrational, whatever it is.
Yeah, exactly. I like it. That's a good thing. In general, you're like, I don't even know what that means. I'm going to put it with the rational. That's a good way to go. That is pi, yeah.
Oh, yeah, that's right.
That's right. Yes?
I know it's 3.4, but when we...
Well, it's 3.141596, blah, 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 forever and ever until everybody just dies and forever. So it's irrational. So 3.14 is not what pi is. It's what you use to estimate pi. But pi just never ends. That sounds great to me. Never-ending pi. Sounds like the time. That's the day you want to go to that restaurant. Oh, look at that. It works. It fits perfect. What's up?
There's number right there.
It's high, not a given, it's a high.
Pi. What's that? With whipped cream? That's what he said. I like, or not ice cream, a la mode. Right? Both. Alright, I like it. What do you think? Chocolate sprinkles. I'm going to move from pumpkin pie, actually. Alright, guys, this is a you know it or you don't question, really. So if you know it, it's quick. If you don't, it's forever. So, counting numbers. Any just pure counting numbers up there?
Yes.
Beautiful.
Well, the
Yes.
square root of 16.
Square root of 16 is? 4. Sweet. So the square root of 16, which is 4, it's a counting. So we'll just write it like 4 from now on. So whenever you see a square root, don't immediately think it's irrational. See if you can figure out what it is and see what number it actually is. So that's a counting number. How about whole numbers?
4, 16.
4 and
0.
0.
And that's it.
Let me write down what we're. Let me rewrite this. Counting numbers is 4. So just rewrite that as 4. Whole numbers 4 and 0. 0 is actually there, so it adds the idea of 0. Now watch what you can do. Integers, you write 4, 0. You got those in the back, and then adds the idea of negative. So I'm going to add negative 7. Rational. Again, you've already got all those in the back. 4, 0, negative 7, plus 4 nights plus 1.1112, not pi yet. Pi is a freaky one, yes.
How come 0 is not part of counting?
Because counting numbers is defined, how do you start to count something? 1, 2, 3, right? If you say, let me count how many people are in here. 1, 2, 3. If you start at 0, then not even you are there. So that's why we call it counting numbers, because we count like that. 1, 2, 3. Whole numbers is where we add the idea of the number that looks like a whole. We add the idea of 0. What about the irrationals? Is anything you haven't listed yet?
Pi.
So in this case, pi.
What is that?
3.14.
1596 forever and ever and ever. So I don't know if you realize 3.1415. So last March 14th is Pi Day for math people. And last year was March 14th, 2015. So we called it Super Pi Day, and we just geeked the hell out. And if you don't think math people could party, you do not understand math people.
Oh, her birthday is Pi Day.
Oh, watch out. You would be... oh my God. The Pi child. Yes?
You're like the Holy Grail for math.
Geeks party, yeah. Geeks know how to party. Especially physicists, man. Physicists know how to down some stuff. Alright, sorry. You know it's true if you're watching this, if you're a physicist. That's what got us through grad school, was a lot of... Alright, what's that? Oh, well, I noticed it as it was happening to me. Alright, so that's 7.1. 7.2, we talked about the different properties, the commutative property, the associative property. So if you weren't here last time, somebody who was here helped me out with this. Which property is this? Is it commutative or associative? Commutative. Individuals commute, parentheses, associative. So this is commutative property of addition, to be complete. Commutative property of addition. By the way, this is 7.2. This was 7.1 over here. What would associative property require? It requires parentheses that get up and move, right? So even if I did this, it's still the commutative property, because what moved? The individuals did. The individuals commute. But if I wrote this instead, 7 times 3 times 2 equals 7 times 3 times 2, that would be associative, because the parentheses got up and moved. That's all I want to say about that. Either you get that right or you don't. There's not much more I can do for you. Ask property of multiplication. Associative property. Section 7. So what doesn't have the commutative property and the associative property? Who remembers? What operations don't have them? Division? Subtraction. The two opposite operations. Addition and multiplication is actually our main operations. Subtraction and division are the opposites of those two. They don't follow these. And we did some examples the other day that shows that they don't. Now, if you see this kind of problem, it says state the property. Don't work this out. It's not what they're asking. But if you did, what's 7 times 6? What's 7 times 6? What's 7 times 6? 42. What's 21 times 2? 42. So of course it doesn't matter what order you multiply it. What?
No.
You good? So really, there's just one more section that I want to do right now. 7.3. That was 7.2. And it's actually a property we've talked about before, if I remember correctly, but maybe not. Parentheses. I got you. I know where you're going. So, this is this kind of thing. If I had 4 times 7 minus x, how could I rewrite that? Yeah, distributive. Did we talk about why that's true? I can't remember. Let me show you why that's true. I think we did, but what does 4x mean? And don't use the word times or anything about multiplication. What does 4x is doing what? What does 4x really mean? See, that's exactly what I said not to do. Don't say 4 times x. Tell me what 4x is doing what?
Adding together.
Adding together. Isn't 4x equal to x plus x plus x plus x? That's what it is fundamentally. X to the 4th power would be x times x times x times x. I like it. So we just chose a different location to describe the operation that was being repeated that many times. It's a nice, concise way to write something. Instead of writing 80 frickin' x's with plus signs, I'm just going to write 80x. Oh, thank God we came up with it. Alright. So what would 4 times anything mean? I write that thing 4 times with a plus sign in the middle. That's what that means, right? No? So what would 4w mean? W plus W plus W plus W, right? What would 4 peanut butter sandwiches mean? Peanut butter sandwich plus peanut butter sandwich plus peanut butter. So what does 4 7 minus x mean? It means 7 minus x plus 7 minus x plus 7 minus x plus 7 minus x. Oh my gosh. And then what can I do? I can use the properties we just talked about. I can use, and just to be sure, I should have put a plus sign to make sure you guys understood. But isn't this plus negative x, plus negative x, plus negative x, plus negative x? There you go. Right? Is that cool? You guys know this. If I had 4 minus negative 2, what happens to these? It becomes plus. I like it. So if I have 4 plus negative 2, what happens to these? It becomes minus. All right. So whenever I add a minus x, I can make it plus negative x, plus negative x. So what's the only operation I have in this whole thing? Addition. So can't I add the 7s together? Because I can use commutativity and move them all together. So I got 7 plus 7 plus 7 plus 7 is 28. What's negative x plus negative x plus negative x plus negative x? Negative x plus negative x is negative. What's happening? What's negative x minus x?
Positive x. No, x. It's x.
Alright. What's negative 1? What's negative 1 minus 1? What's negative 1 plus 1 then? That's 0. Negative 1. So what's negative 1 mean? Negative 1 means you're 1 down, right? If I go another 1 down, I am now 2 down. Okay, so let's negative x minus x, negative 2x. Another negative x, negative 3x. Another negative x, negative 4x. Don't I have 4 negative x's? So minus 4x. So please, dear God, let me immediately tell anybody who's sitting there thinking, this dumbass teacher is making me do all this shit. No, this is why this works. Right? I mean, that's why the distributive property works. What's 4 times 7? 28. What's 4 times negative x? Negative 4x. So that's, and you gotta love the name. We don't get the names right very often at all in math. But we got this name right, this freaking distributive property, because we distribute that to both. Okay, I like it. So please, dear God, never do this. There's no need for this. This is why this property works. So just do the property. So what have I had this year? Yeah. What do you distribute the 5 to now? You distribute the 5 to the A. So what's that? 5 times A is 5A. Minus 10B. Plus 15. C. You guys see that? So, if I do the 4 times everything inside, I do the 5 times everything inside, I could have 18 things inside, and I just take the 5 to each one of them. I'm not going to do that, because I have to turn the test paper this way. But I'm just trying to show you the distributive property doesn't care how much stuff is inside. It just keeps going until it gets everywhere. What about this one here? Bless you. Yeah, negative 4 times 5 is negative 20. Negative 4 times negative 7x. Now the most common mistake is if I put a number here, for some reason people forget to do negative, this stays negative. I don't care if I put a number here, like if I said 6 minus 4 times this. I still put the negative 4 times 5 is negative 20, and the negative 4 times negative 7x is plus 28x. Now there's just a 6 sitting there, and then I can put my like terms together now. Why did I do this first? Why did I put the 4? Why didn't I do 6 minus 4 is 2? Because that's what 6 minus 4 is, Jeff. Come on. Why didn't I do that?
Because the price.
Yeah, what's the 4 doing to this? Multiplying. And do I multiply first or subtract first? Freaking multiply first. So there is no 2 here. There's a 6 minus, I don't know yet. So the 6 just kind of sits there until this stuff figures itself out. Now what's 6 minus 20? Negative 14. For example. I like it.
Why does it become addition from subtraction?
Because negative 4 times negative 7 is positive 28.
So it would change the sign.
Yeah, so if there's a negative out front, it's going to change all the signs throughout the whole thing on the inside. Because everything's getting multiplied by a negative, and what happens when you multiply a negative? You change the sign.
That's only when you do a negative by a negative, though, right?
Well, no. What was this 5? This 5 is, right now, this 5 is positive.
Right.
When I multiplied by negative, it became a negative. So it changes the sign.
When you multiply the negative 4 by the negative 7.
It changed the sign and became positive.
All right, what if that's a 7 to the power of 2 with an X on it? Can you do that?
Don't do that. I'll leave that alone. Don't give me ideas. Alright guys, try to simplify this here.
Or maybe if you went within your eye. That would be awesome.
What's up? Oh, let you know when I'm ready. To do it? Yeah. Give them a minute.
I know I got it wrong, but
I see.
I got 8. 8 Y. Is that a Y?
I got negative 7 plus 15. 7 plus 5 was 15. Never mind.
No, you're okay, Jim. All right, let's see. So, what are you going to distribute in here? What are you distributing? Negative 3.
Negative.
So you put the 11. The 11's just sitting there waiting. The 11 is just sitting there waiting. So negative 3 times 6. Negative 18. Negative 3 times negative 5y. Positive 15y. So I don't know why this number always throws people off. If it was this, a lot more people would get it right. But the minute I put a number there, people forget to bring the negatives through.
That's rough job.
Oh, it's always on the right side, that means, right? Like if it's like, no.
Oh, I think I see what you're saying. 11. So 11 minus 18?
Negative 7.
Yeah. So if you got that, you're good. If you went further than that, you ain't good. Something's wrong. They're not like terms, so you can't put those together. All right.
So you can't put the like terms together if the equation's over?
You're done. Yeah, this expression you simplified.
Okay.
There's no equation, so you can't solve for one.
Okay.
Yeah. Some people like to make everything in the world equal to 0. I think that's a pretty bleak view. Right? The universe is 0. Very nihilistic, I don't know. We are all meaningless blobs of existence. What about this here? Let me do something that I think is related to a question Jackie just had, but maybe not. See, the minute I do this, people freak out a bit, but if I told you what m was, this 4 minus 7m would be a number. So I got a number times 2. So if you really wanted to, you could just put the 2 in front. But realize that it don't matter what side the 2 is on, the 2 is going to go through to both. What am I multiplying by 2? Both of these. They're both being multiplied by 2 because they're in parentheses. So 2 times 4? 2 times negative 7m? Please don't make that negative 6m. Right? They're not like terms, so you can't put those together. Don't go too far. Don't do it. You can stop. You cannot delete. See what else freakiness they do to you guys. Bah. No, there's nothing too freaky in here. Here, what about, okay, here we go. You ready? Here's the freakiest problem in there.
You still on 7-3?
Still on 7-3. That's as far as we're going for the next test. We'll do 7-4 for the test after. So your homework is only up through 7-3. It says that on the updated homework sheet. Yeah, I'm going to get you guys started on this one, and I'll pass out the practice test while you're starting to work on this one. I like it. Ooh, that problem is gruesome. I like it. It's not too bad.
It's horrible.
Forget practice. Yeah.
So yes, I am.
What do you get? All right, guys. So 6 times 7y, 42y. 6 times negative 2n, negative 12n. Now, there's a few different ways to look at this, but that negative is acting on both of these. Do you see that? So if you want to, you can think of it as there's always what in front of something. So if I write a y, what's in front of that? A 1. So if this helps, you could just put a negative 1 there. So then you're taking a negative 1 times both of those. If you don't need to do that, then don't do it. But if that helps you, that's actually what's happening. There is an understood 1 there that we just never write unless we need to. So what's negative 1 times 3m? And what's negative 1 times